Today we are doing lesson 3.1, 3.3, day 3, and these are rules for differentiation. The rules that we learn today will help us to take derivatives more accurately and faster. We don't have to use the different equations that we learned for the definition of a derivative and the alternate definition for a derivative anymore, except maybe once on a test. And you do need to remember them because they are on the AP exam. But let's start with rule number 1, the derivative of a constant. Anytime you have a constant number and you take the derivative of it, that derivative is equal to 0. So if your function equals 4, your derivative is 0. How wonderfully simple is that? The next rule is the power rule, which we use all the time for polynomials. All right, so find the derivative of y equals x4, which x to the fourth, which is a polynomial. What you do is you take the power of the x term, put it in front, right here, and then you subtract a power from the exponent. So in the case of y equals x to the fourth, we have y equals, take your 4 and move it in front, 4x to the, and then subtract 1 from 4, 4x to the third. All right, this works for all terms in a polynomial. So for the function x to the fifth plus 1/3 x cubed minus 2, let's take the derivative of that. We take the 5, move it to the front, 5x, and we subtract 1 from the 5 to give us a 4. We add 1/3. 1/3 is just a constant, and we'll talk about that rule as the next rule that we talk about. So 1/3 times x cubed is 3 x's and square them. Now the derivative of the negative 2, we just said that equals 0. The derivative of any constant is 0. So let's clean up this answer just a little bit to make it look nice, and it becomes 5x to the fourth plus 1/3 times 3 cancels out, so it's plus x squared. That is the derivative of your original function. Next, like I said, we're going to do the constant multiple rule. Whenever you have a constant in front of a function, u is a function, you take the derivative of that function and you multiply times the constant. So here's an example of a function, 4x to the fourth. We have a constant multiple, which is 4, and then we take the derivative of x to the fourth, which is 4x cubed. Simplify that out, it's 16x cubed is your derivative. The next rule is the sum and difference rule, which we've really already used. And that just says when you take the derivative of a bunch of terms, you add them all together. Okay, so this is 8t cubed. The derivative of that is 8 times 3 to the t squared. The derivative of 7t squared is 7 times 2t to the 1. Now, when you take the derivative of negative 3t, negative 3, you get 1 times t to the 0. All right, now don't forget that anything to the 0 is a 1. So t to the 0 equals 1. And then the derivative of our 5 is plus 0 because the derivative of a constant is always 0. So again, let's simplify this up. 24t squared. We have 7 times 2, which is 14t. And we have negative 3 times 1 times 1. That is just a negative 3. That is our derivative for the given function. Next, we have horizontal tangents of the curve. This is, remember when the derivative equals 0, we have a horizontal tangent. So we're looking for places where m equals 0, which is the derivative equals 0. So let's take the derivative first using our newfound rules, and instead of using the difference quotient or the other derivative definitions. We have 4 times t cubed minus 2 times 2t to the 1, and then the derivative of 2 is 0. All right, so our derivative function is 4t cubed minus 4t. Now, we said we're going to set this equal to 0. When we set a function like this equal to 0, in order to find the t's, we need to factor it. So let's factor out a 4t, and you get t squared minus 1. And t squared minus 1, we know that's the difference between 2 cubes. So now, wow, we actually have 3 points that are given that this derivative equals 0. We have 4t equals 0, so that means whenever t equals 0, we have a point. We have t minus 1 equals 0, therefore when t equals 1, we have a point. And last but not least, we have t plus 1 equal to 0, and therefore t equals negative 1 gives us a point. So we should find each one of these points. So what we need is to find the y value for each one of them. All right, so here's our original function. And the function value or the y value is when we plug in each of these t's. So let's plug in a 0 into the function, and we get 0 minus 0 plus 2. So this point is 0, 2. The second point is when we plug a 1 into this equation. So we have 1 to the 4th minus 2 times 1 squared plus 2, which is 1 minus 2 plus 2. That gives us a 1 for our y value. And lastly, we're going to plug in a negative 1. So we have negative 1 to the 4th, that's just a positive 1, minus 2 times negative 1 squared, that's also a positive 1, so negative 2 times 1 gives us a negative 2, plus 2, this y value is also a 1. So these are the 3 points where we have a horizontal tangent. All right, so that's the answer to that kind of a problem. Find the derivative, set it equal to 0 to find horizontal tangents. Okay, next, product rule and quotient rule are 2 very important rules we use all the time in calculus. All right, this is when you have a function times a function. If you have a function times a function, you take the first function times the derivative of the second plus the second function times the derivative of the first. Oftentimes, I will write it like this, uv prime plus vu prime. So what we're going to do first is establish a u and a v, and then we're going to find both of their derivative values. So u equals x squared minus 1. U prime equals the derivative of that, which is 2x plus 0, because negative 1 derivative is 0. All right, the v value is equal to x plus 21. The derivative of v prime, equals 1, because x to the 0 is 1, and the derivative of 21 is 0. So what I like to do is write it like this, so then I multiply my u times my v prime. So I have 1 times x squared minus 1. Okay, so that's the first part of my derivative, plus the other 2 multiplied together, v times u prime. So we have 2x times x plus 21. Okay, all we have to do now is simplify this, use our algebra skills. X squared minus 1 plus, don't forget to distribute, 2x squareds plus 42 x's. All right, so we have x squared plus 2x squared. That's 3x squareds plus 42 x's minus 1. I like to write this derivative function in standard form, and that should be our answer. That's an example of the product rule. The quotient rule is very similar, except it has a different formula. The formula says that if you have a function divided by a function divided by a function, you take the first function times the derivative of the second minus the second function times the derivative of the first, all divided by the original v function. All right, so you have to set things equal to u and v and don't get them mixed up. All right, so I also like to write this formula in the format using primes as opposed to du dx's, just because it's a little few less pen strokes. All right, so when we do this, we're going to have our u divided by our v. So our u is going to equal x squared minus 1. And therefore our u prime is 2x. Now our v is equal to 3x. It's the denominator. Therefore v prime is just a plain old 3, because the derivative of 3x is 3. All right, so let's be reminded of our formula here, and let's plug all of these things in. All right, so the derivative of x is equal to v, which is 3x, times u prime, these two, times 2x, minus. Sometimes I like to make a bracket here because people forget to distribute the negative. So we have u times v prime. U is x squared minus 1, and v prime is 3. So you need to make sure you subtract this entire quantity. All right, and we divide that by v squared. Here is our v, 3x, so 3x and the entire quantity squared. Now, all we have left to do, this is the hard part, and this is where most students have the most trouble. They get everything plugged into the equation right, but they mess up on their algebra. 3x times 2x is 6x squared, minus 3x squared. Don't forget to distribute this. And this is a minus 3, so a minus minus 3 is plus 3 over 9x squared. Remember, 3 squared and x squared. All right, so that equals the derivative at x. Well, that's probably good enough, although we could factor out a 3 on the top and the bottom. So if you did that, you would have to divide everything by 3. Every term here could be divided by 3, top and bottom. So you would have 2x squared minus 1x squared plus 1 divided by 3x squared. Oh, I can actually combine these, can't I? 6x squared. I can. All right, so 2x squared minus 1x squared just gives you 1x squared. Aha. All right, so make sure you simplify it down to the lowest denominator here, and that is the product rule. I know I went very fast, but please use the stop function of your video and make sure you can take good notes, because you will be turning your notes in. That's the end of rules for differentiation.